This question is about quadratics. The first one, we've got it in completed square form. And once you've got it in completed square form, there's lots of things you can do. For example, you could solve it and find the roots. They're going to be quite horrible irrational numbers here. We could do that, but something else it gives us is actually this turning point that the question is talking about. And the thing on the left is always going to be greater or equal to 0. It's not possible for it to be negative because we're squaring something. And so the smallest it can be is 0, and therefore the smallest the function can be is -3. It can't possibly be any smaller than that, like more negative. Now, when is it going to equal -3? It's going to be when this bracket is 0, so it's going to be when x is 2. And therefore, we're going to get 2 minus 3 is the minimum here. Why did I write -2? 2 minus 3. And then we just need basically to draw a quadratic that will match with that. I think I'm going to add one other thing. Like, I know that when x is 0, I think I'm going overboard here. When x is 0, y is going to be 4 minus 3. It's going to be 1. So I do know it's going to go through the axes. It's not going to be here. It's going to sort of come down like this. Okay, and that's enough. I've got my quadratic, I've got my turning point labelled, job done. Second part, we've now got a quadratic in expanded form, and we're given the graph, and we're asked to work back to find a and b. Okay, these are the roots. Now, when you solve a quadratic, you take the negative, like after you factorize it, you take the negative to get the solution. And we can do the opposite here. It must be that the quadratic has the form x plus 3, x plus 1. Because if you were to solve that equal to 0, you would get the solutions -1 and -3. But is that the quadratic? Well, that does not cross the axes at 12. So it must be that we've got some number in front. And I know that when I multiply these two, I'm going to get 3. Therefore, if I want to get 12 as my intercept, I'm going to have to multiply it by 4. So it's going to be a 4 here. Right, so we're basically done. Okay, I'm just going to say it again, I think. So I've got the roots as -1 and -3. That means that when I put it in factorized form, I can put a 3 here and a 1 here. That's absolutely fine. However, that is not necessarily the solution because I could multiply this by anything and I just get like different quadratics. You know, it might look like that. It might be sort of, well, that didn't go through the axis, but you get the idea. It might be a bit, let's have another go. It might look like that. Okay, and you just get these different places where it crosses the axes. Now, when x is 0, I suppose I didn't say that before. When x is 0, I want to get 12. I only get 3 at the moment, so I need that 4 there to make it work. So now I can multiply this out. It's going to be 4 lots of x squared plus 4x plus 3. I've expanded that quickly, and then that's going to become 4x squared plus 16x plus 12. And I've got my c. Even if you struggled with this question, like learn to recognize that a graph crosses such as this, or y equals mx plus c. C is the intercept. Some of the other, like the a and the b, are more difficult, but a is going to be 4, and b is going to be 16.